Okay, we are live. Okay, so we can start. Good morning, everyone. I'm Sakshi Nalaude, Head Coordinator for AICVS CCOEW Pune. I welcome you all to the today's session. AICVS is an artificial intelligence and computer vision society of Cummins College of Engineering. It is a club for artificial intelligence and machine learning enthusiasts. Kaggle competition can be the great way for the beginners to build their data science skills. It will also expose you to a wide range of machine learning problems. Our speaker Krutika Kulkarni will provide you a deeper insight, helping you to kickstart your journey with Kaggle. Krutika is a final year ENTC student at Cummins College who is a machine learning and deep learning enthusiast. She completed her summer internship at Walmart Labs, where she worked in the domain of backend development. She is currently placed at SAP Labs as a cloud developer. She was former project and internship head at AICVS Cummins. She loves to apply various different algorithms in ML and DL to solve the problems in domain of computer vision, natural language processing, pattern recognition, and so on. Now, without wasting any more time, I would request Rutika to take it over from here.
Thank you for the wonderful introduction, Sakshi. I'm super stoked for conducting today's session. And hello, all smart people who are watching this stream live. Let me quickly share the slides. I'll share my screen with you. So, today we are going to be talking about how to get started with Kaggle. So let's first see who the target audience is. If you guys have already participated in a few Kaggle competitions, if you already have the expertise of working or playing with the data sets, you can safely skip this session. This session is targeted for machine learning newbies, people who are well versed with rudimentary Python, and techies with an appetite for learning. This session is specially meant for those students who are stuck in the tutorial hell. So, I was there in the same situation a few years back. So, I think I might be able to help you guys out with it. So, let's see what comes ahead. The road ahead. Today, I'm going to be accompanying you in this journey of trip down the Kaggle lane. So, I'm going to be there with you guys for an hour. I'll be sharing different tools and techniques that you can just learn for working with various data sets. So, let's see what we are going to do today. What is our agenda? So we'll be working with three different data sets. The three different data sets are like Gapminder, then we have the Boston House Price Prediction data set, and last but not the least, we are going to be working with the breast cancer prediction data set. We'll be learning about various machine learning and data pre-processing techniques. We'll be learning about exploratory data analysis. We'll be having a brief overview of various algorithms like linear regression, logistic regression, SVM, random forest, artificial neural networks, and there's a lot of things in this course. So, yep. Just in order to save some bandwidth, I'll be switching off my camera for a while, and later on, I'll be starting it again. Okay. So now we've been talking about getting started with Kaggle, but what is Kaggle? So Kaggle is a website where you can find really good quality data sets in varied domains. It also allows you to publish your own data and codes via Kaggle notebooks. It provides us with top-notch GPUs and TPUs for our ML projects. And last but not the least, it is a wonderful community of data science researchers and enthusiasts who are doing a great job. So next, where can you code? So for coding, you can use anything like Jupyter notebooks, IDs like Spider, PyCharm. We already talked about Kaggle notebooks. You can leverage them for coding purposes, or your most safest bet is going to be Google Colab. where they also provide their own GPUs and TPUs, and it's a great way to code. And you can also share these notebooks with everyone, and you can collaborate and code together. So let's take a look at the procedure to work with any data set. So there are 5 basic steps which I'm going to be walking you guys through. Those 5 steps are as follows. Like the very first step, as soon as you get the data, you need to understand the problem statement. You need to identify what type of problem you are going to be solving. Okay, so this is our very first step, when you really need to figure out the crux of the problem, that oh, I need to do this, I need to figure out these steps for getting a particular output. So once you've done that, the second step is to load your data set and import all the necessary libraries. Then the next step, and the most important step in any machine learning project, is to carry out exploratory data analysis. It helps you to gain insights from the data. Another necessary step is doing data pre-processing. And the very final step is building and evaluating models, making predictions with them. And if at all you're participating in any Kaggle competition, you need to make a submission as well, right? So we are going to be looking at these steps one by one, and we'll be gaining a high level overview of what each and every step means. And so let's move on to step one. So step one is as I told you, it's the identification of problem statement. The problems that we are going to be dealing in this session today are going to be the regression problems and the classification problems. Regression problem is the one wherein your task is to predict a continuous quantity, and classification problems are the ones where you have categorical target variables that you need to predict the class to which a particular data point belongs to. So for regression, we'll be using the Boston House price prediction dataset, and for classification purposes, we are going to be using the breast cancer prediction dataset, and we'll be looking into various classification algorithms like logistic regressions, SVM, so on and so forth. So yeah, that was all about the very first step. So moving on to the next step. Um, the next step was about importing the libraries and loading the data set. These are a few important libraries that you will be using for your machine learning project. The first one is NumPy. This library is very much useful for carrying out numerical calculations, like sometimes you need to do some indexing work, you need to do reshaping, sorting, so on and so forth. So for all these mathematical type of stuff, NumPy comes in really handy. So then moving on to another important library, that is Pandas. Pandas comes to our aid while we are dealing with manipulation of the given data set. We can use Pandas to load our CSV files or our data set into a data frame and perform all sorts of manipulations on the rows and columns of it. And then a few important data visualization libraries which we are going to be using for exploratory data analysis are Matplotlib, Plotly, and Seaborn. So now let's talk about scikit-learn, because we are going to be using this library extensively. So we'll also talk more about that later on, but I'll just give you a brief overview of what this actually does. So scikit-learn, this is the library that has functions or pre-configured models, both for supervised as well as unsupervised algorithms. It helps us to train and evaluate our model efficiently with different algorithms. It has a predefined model for linear regression, logistic regression, SVM, and much more. So we are going to be using this a lot in today's session. And last but not the least, we have Keras. Keras is a deep learning API which is written in Python. It works in coordination with TensorFlow. This we are going to be using Keras for creating our very first artificial neural net. So we are going to be leveraging this one extensively for creating all those hidden layers, creating the sequential models. So yes, this was a brief overview of all the libraries that we are going to be using. So now let's see what do we need to do for loading a data set. So first we need to download the data set, and we need to import our pandas library, the one which we talked about uh, some time back. So we have to store the data set, that is the CSV file, in a data frame. So in place of data.csv, you can put in the location of the data set where you stored it, and then you can start playing around with it. So see, loading the data set is as simple as that. And yep, step 3, exploratory data analysis. This is hands down the most important step for any machine learning project, as I said earlier. It helps you to create really good ML models. So what is EDA about? So EDA can be described as a process of like investigating the data set and discovering the patterns and anomalies in our data. It helps us to analyze the existing data and gain some insights from it. So EDA involves generating summary for statistics of numerical data, creating various graphical and visual representations of our data. It's just done so that we understand the data better. Okay, so it also involves checking a few entries within the data frame. We can use df.head and df.tail for that. So we'll see that. And yes, so it also helps us to count the number of nulls and nans, and yeah, it is very useful for understanding the hidden pattern, the undercurrent behind the data. So before we go ahead, I really wanted to show this really interesting library called Plotly on the Gapminder dataset. It can be used for creating beautiful visualizations and animations. It really helps us to gain more from less, and all of this can be done just within the few lines of code. So I hope you are able to see the Gapminder notebook. Sakshi, is it visible? Okay. So, um, so first after loading the data, we just check gapminder.head. It gives the first 4 to 5 entries of our data. Then what we can do is that we can create a tabular representation of data, and we can also create some really cool bar charts. So, but what is so great about Plotly? We were able to create bar charts with Matplotlib and Seaborn as well, right? But the cool thing about this is when you hover over any particular any particular bar, you're able to see the data. Like here, you're able to see the year, the population over that in that year. So yeah, this is the main advantage of Plotly, that you'll be able to get more insight from your bar charts. And yes, this is another bar chart wherein we have colored all these bars on the basis of life expectancy and so on and so forth. So again, if you hover over it, you get more details about it. And so yeah, so we can just create these scatter plots for various different features that are present in our data. We can group them according to the continent and the country. I'll be showing about the countries later on. So when you hover over this, you get the continent for which the bubble belongs, the GDP per capita, and also the life expectancy. So another important use of Plotly is that you can create this wonderful bubble charts, which again give you a lot of insights about the data. So this is about the country. So let's check what we have for India. So it is saying it's an Asian continent. The GDP is given, the life expectancy is given, and yes, the cool thing about Plotly is that you can really create these wonderful animations. They are very interactive. Like I'm gonna play this one for you all. So you'll be able to see the transition, how it is happening. So in year 1972 this was the situation, and then later on this is changing like this. So yeah, so we just saw the transition from the year 1952 and 2007 via this animation. So I think that's super cool. Again, so not just animated and interactive bubble charts you can create with this. You can also create like these animated maps, which give you a lot of insight about what is happening in different continents and stuff. You can hover over it, you can even turn this globe by just your cursor and stuff. So I personally think this is very cool, and you can use the uh, choropleth for creating more of these interesting visualizations. That the color coding and all that stuff is really cool. And yeah, this is an animation, so you're able to see what the life expectancy is in various areas. So yeah, these are some of the things which Plotly does very nicely for us, and just with a few lines of code. And by the way, this is not my own code. I have taken this one from Kaggle. So yeah, so shout out to Kaggle. So we saw briefly about Plotly. Now let's just see about our breast cancer data set. Let's do exploratory data analysis on that. So here we've imported a few libraries. Then yes, if we scroll down a bit, when we do df.head, as I told you, we have gotten these first 5 entries. Then we can do df.data types. What this does, that it shows you all the features and their data type. Okay. So, and df.shape, it tells you about the number of rows and the number of columns in your data frame. So right now we are having 569 rows and 31 columns. So now, most important thing in any machine learning project, you first need to check out for the number of nulls and nans. But here, this was a really good data set, I believe, because we have no nulls and nans over here. Because I use this code like df.isnull.sum. What this does is that it finds the total number of nulls that are present in each of the columns for your data frame. But luckily, we don't have any one of them. So good for us. So what we can do, we can create a count plot for we can create this count plot for different target variables in our data frame. So since this is a breast cancer data set, the target variable contains two different types, like two different categories of variables, 0 and 1, wherein 0 means the type of cancer is malignant, that is, it is cancerous and harmful, and 1 means it is benign, uh, implies it's not that harmful. So yes, again, once again, for creating a diagnosis count plot, I have used Plotly, so that we get the exact number for zeros and exact number for ones. So so we have 212 malignant cases and 357 benign cases. So yeah, okay. So that was all about the count plot. Now let's talk about this correlation matrix. So the correlation matrix gives us the visual representation of how different features are correlated to each other. The features that have the higher value implies that they are highly correlated with each other. And mostly in machine learning, you just drop a few of the highly correlated features because they don't provide you any additional special insight, right? So this was about correlation matrix. Since we have like 30 features or 31 features, actually we have 30 features excluding the target variable, that is diagnosis. Our correlation matrix is quite big. It's really big. 30 by 30 is a lot. So yes, so this is building a correlation matrix with heat map is one good way of checking out for the correlation between different features in our data. And another thing for checking the correlation, collinearity, what we can do is that we can do a pair plot, which gives us the insight about how different features are related to one another. So, as I told you, that this data set has quite a few features, like 30 by 30. So, this doesn't look all that great, but yes, it's insightful. Where we can see these straight lines, we can understand that these features are like really correlated to one another. So, you know, um, just for the sake of reducing the um, computational expenses, what we can do, we can drop few of these features. And for dropping a few of these features, we need to first find out, with the help of exploratory data analysis, which features are relevant so that we can store them and we should not drop them, right? So this can be done by various ways. The first one that I told you was by looking at the correlation matrix and at the pair plots, because they tell you about the correlation of the various features. And another cool way of doing that is with the help of univariate analysis, or it is also called as feature selection. So for doing that, what you need to do, sklearn has already made our lives very easy, because we just need to leverage the select k best and chi squared model for doing that. So um, so as I told you, univariate analysis is just a feature selection technique, and chi squared test is used in statistic to test the independence of the two different features in our data set. So, this is the code for the same. In X, I have stored all the independent columns, and in Y, I have stored all the dependent columns, like the diagnosis, the diagnosis variable, that is the column which was having zeros and ones. So now we just apply select k best, and we select, with the help of select k best and chi squared, we select top 10 important features that are present in our data frame. So like these are the features and these are the scores. So now we can understand that, worst area is one of the most important features in our data set, and so on and so forth. Um, so with this we can have these important features. And when it comes to feature importance, what we can do there is this feature importance thing, which gives you a score for each feature on our data. And higher the score, more important or more relevant the feature is in our data set, towards our output variable, obviously, which happens to be diagnosis in this case. So feature importance is an inbuilt class that comes with like any tree based classifier. And we'll be using the exploratory classifier for extracting top 10 features from our data set. So yes, so whatever I said, I just wrote it down in Python. From sklearn, I imported this exploratory classifier for extracting top 10 features. So this is a really cool bar chart that it shows for the feature importance. And whatever we saw earlier, so when we did feature selection, worst area was most important, and feature selection has feature importance is also given us the same results. Here also we can see worst area has the highest score, so it is very important for our data set towards predicting our output variable. So up till now, we just saw three techniques of finding out the important features in our data set. The first was correlation matrix, the second one was feature selection, the third one was feature importance. And I would like to throw light on another important technique that can be used for selecting important features in our exploratory data analysis, and that is PCA. PCA stands for Principal Component Analysis, and it is a widely used technique for reducing the dimensionality of multivariate data sets. What are multivariate data sets? So these are the data sets that have a huge number of features and variables. So the main job of PCA is to increase the interpretability, but at the same time minimize the information loss. Because quintessentially, what PCA is gonna do is that it's like it's gonna remove all the features that are not important, right? So yes, so this is what PCA does for us. It creates new uncorrelated variables that successively maximize the variance. So again, we can leverage the ready-made PCA model from sklearn. I told you already that we are going to be using this sklearn thing a lot for our purposes, for our machine learning model today. So, so this is what we are doing. We are importing PCA, and we are dropping the highly correlated columns, which are not useful in our case because, as I told you, they do not give us any valuable insights, any new information about our data. So, so first we scaled our data using the standard scaler. So I'll be talking about standard scaler more in the data pre-processing part. So hold on, this is something that we'll address later on. So now we apply PCA on our scale data set, and here n component signifies the variance that we are going to apply. So in our case, we have set it to 95%. So yes, after after applying PCA, the 30 features that we had initially are narrowed down to 11 ones. So what we are getting is that we are eliminating all the less important features and we are keeping all the relevant data only in our data frame, right? So now that we have the idea of all the important columns in our data, what we can do is that we can drop the unimportant columns, the columns that are not very important from our data frame, or else we can create a new data frame that contains all these columns, and we can use that new data frame for building and constructing our machine learning model. Okay. So yeah, that was about all the important feature selection techniques, and like we saw about feature importance and all that stuff. So that is why I say PCA and these all these techniques which are a part of EDA are very important, are like super duper important when you are making a machine learning model. So before we go ahead, what I want to talk about is splitting our data set. Now what we need to do, we have our data frame which contains like 569 rows and 31 columns, right? So for the simplicity purpose, I haven't dropped any of the columns. I'll be using all of the features. If you wish to drop all the unimportant ones, so I heavily encourage you. After the session ends, we are going to be sharing all these collab notebooks with you, and maybe at that time you can make a copy of it and just play with it. You can do various different things with it. So I leave that up to you. But for the sake of this session, I'll be keeping all the important features, like all the features for that matter, all the 30 features that are there in our data. So here we are using the train test split function from sklearn. So what we are going to do, we had this giant data frame, right, of 569 rows. We are going to split that in two different data frames. Like one is the training one and the other one is the testing one. So here in the X train and X test, what we need, we in the so for the X train and X test, we need the features, the independent features. That is all the 30 features, that was area, mean radius, perimeter, and all that stuff. And in the Y train and Y test, we only need the target variables. So what was the target variable in our case? It was diagnosis, right? Which was the variable that was telling us whether the cancer is benign or malignant. So that is what we are doing. So for X train and X test, we will be dropping the diagnosis column, and for Y train and Y test, we'll be putting that diagnosis column in these data sets. So now test size is 0.2. What does that mean? It just means that 80% of our data is training data, and 20% of our data is the testing data. Okay, so here you can see that in the training data set we have now 455 columns, and in the testing data set we have 114, sorry, 455 rows in the training data set, and in the testing data set we have 114 rows. So that is how train test split works. So yeah, that was the thing about EDA. So now another important step in machine learning is data pre-processing, right? So in data pre-processing, what we need to do, it is the very next step after EDA, and we need to make a few changes and do a few manipulations in our data before it is fed to the model. It involves data cleaning, standardization, um, normalization, so on and so forth. For our case, we have just used standardization, but I'll also be talking about normalization. So, yes, so let's go to the standardization part. So what are we doing in standardization is that basically we are actually using the standard scalar function from sklearn library, and with standardization what we are going to do is that we are going to center our values around the mean with a unit standard deviation. This means that the mean of all the attributes becomes zero, and the resultant distribution has a unit standard deviation. So for all of that, we just need to import the standard scalar and fit the standard scalar to our training and testing data sets. So yeah, that was all about standardization. Standardization is a very important technique in feature scaling. What it does that it gives a way of comparing two different features that are there on two different scales, and it is heavily useful in our machine learning models. So yes, so now let's talk about building models, which is the most interesting part for you all, right? So, which also happens to be the step five in our machine learning roadmap that we saw earlier. So, first one that I want to talk about is the linear regression. So, linear regression is the supervised learning technique that is useful for predicting continuous variable values. Here y is the dependent variable and x is the independent variable. So hypothesis for the linear regression looks something like this: y equals theta 1 plus theta 2 times x. So as soon as you look at this equation, does it look similar to something that we've seen earlier, maybe in our school life? So it kind of looks similar to the straight line equation, right? Y equals mx plus c. Here, theta 1 is the bias or the y-intercept, and theta 2 is the vector for all the weights that our model is going to be learning, and x is the vector of all the features that are present in our data, that are present in our input data. So this was all about the hypothesis of linear regression. So now, for predicting any output, what we need in linear regression is that we need to have a cost function. And here, the cost function that we have used is mean squared error. So what this does is that this loss function computes the difference, the square of the difference between the predicted value and the actual value. Okay, so and the goal of any linear regression model is to minimize this cost. And how does it do that? For that, it uses this another machine learning algorithm, which is known as the gradient descent algorithm. Okay, so what this gradient descent algorithm does is that it starts off with random theta 1 and theta 2 values, and it keeps on iteratively updating these values till we reach some minimum cost. So this is how the gradient descent works. Again, since we, because of the time crunch, I'll be only able to give you the high level overview of how things are working. But the maths behind this, the equations that are involved in this, is something I really encourage you all to look into. So as of now, we'll just jump into the code snippet of it. We'll just see how we can perform linear regression with the help of sklearn. So again, we are splitting our data set. So right now, for regression purposes, as I told you earlier, we are using the Boston house price data set. So yes, so once we have downloaded the data set, I have already done some of the EDA and all that stuff before. After we share the notebooks with you all, you can just maybe go through it, skim through it if you want to. But right now, for making a model, what we need to do is that we need to split our data into training and testing sets. So we've done that with the help of train test split, which we saw earlier. And what all I told you, like generating hypothesis, then cost function, gradient descent, we don't need to write a code for all of that. Like when you're doing competitive coding in C++, do you write the sort functions and all that all by yourself? No, right? You leverage the STL library for that, right? So same way, as I told you, we'll be using the sklearn's linear regression model, which does all of this, which generates hypothesis, minimizes the cost function using gradient descent, all of that behind the scenes, right? So here I've just initialized a classifier with a linear regression model. Just put in the training data set, and just we are fitting the linear regression model on the training data set, and we are making predictions, right? And here we have evaluated the predictions with the root mean square error. So this is the error that we are able to get. So yes, this was kind of like the high level overview of linear regression. So, and this was used for continuous variables like price. It's not a categorical variable, right? You need a number for price. It cannot be um, narrowed down to some class or something. So this was one algorithm that I thought of talking when it comes to regression cases. But for classification problems, uh, I'll be talking about logistic regression, SVM, and random forest and neural nets as well. So yeah, let's hop into logistic regression. I know this is a lot of information for one session, but we are on this time crunch, and don't worry, everything will be pellucid when once we see the codes. So yes, we come to logistic regression. Logistic regression is also a supervised machine learning algorithm, which is used for binary classification problems, meaning that there can be only two possible output classes, either zero or either one. The same thing that we saw in our breast cancer data set, 0 and 1 were the only possible classes, benign and malignant. So, yes, now what? Logistic regression is strictly used for categorical variables only. Now, what logistic regression has to do is that it needs to find out the probability of data point belonging to a particular class, and then on the basis of threshold that we are going to set, it assigns the data point to any particular class that has been predicted. So our hypothesis over here is this: Z equals x1 w1 and x2 w2 plus b, where b is the bias, w1 and w2 are the weights associated with the two features x1 and x2. So now, since we are speaking of finding the probabilities, the one thing that we know is that for finding the probability, we need to shrink our values between 0 and 1. And this is where the sigmoid function comes in handy. So the sigma of z is 1 upon 1 plus e raised to minus z. This is nothing but the sigmoid function, which will shrink the values that are generated by this z hypothesis to 0 and 1. Okay, so in most of the cases, like we saw in linear regression, that we were using mean square error as our loss function. But since we are dealing with categorical data, the loss function that we are going to be using here is the mean square error one. So we are not going to be using mean square error. We are using this cross entropy loss function. And so, yes, that was a high level overview of logistic regression. This is how it works. So we get the z hypothesis, then we put it to sigmoid function. Sigmoid shrinks the values between 0 and 1, and so whatever values have been generated, if they are below above the threshold, that is here the threshold has been set to 0.5, it gives the output as 1, and if the threshold is less than 0.5, it gives us the output as 0. So, and again, the loss is minimized with the help of gradient descent, and gradient descent works the same in logistic regression as it did in linear regression. So let's jump into the code for this. Okay, so here what we are doing is that we are just importing this logistic regression function from sklearn. We are fitting our training data and we are making predictions. Okay, once we are making predictions, another important aspect associated with it is that we need to evaluate what the predictions are, right? So for that we are going to be using the confusion matrix. So this is what the confusion matrix with the heat maps looks like. So um, this 71 indicates the number of true positives, 0 indicates the number of false positives, 2 indicates the number of false negatives, and 41 indicates the number of true negatives. Then we'll be printing out the classification report and we'll be finding out the accuracy of our model. And surprisingly, we got a very good accuracy of 98.2%. So that was pretty dope for simple algorithms like logistic regression, right? So here the logistic regression part comes to the very end. Now let's talk about another important algorithm, which happens to be SVM. So SVM stands for support vector machines. It is a supervised machine learning technique that can be used for both regression and classification problems. But here, today in this discussion, we are going to be using it only for the classification problem, and that too a binary classification problem. So, in order to understand SVM, let us consider a very simple example. Suppose let us consider we have a farm filled with wolves and rabbits, and we need to construct a fence around them so that our wolves do not eat our rabbits. So, how will you do that? So one possible thing is that you will draw this boundary between them such that it differentiates these two groups, and this is how exactly SVM works. It draws a decision boundary which is called as hyperplane between those two classes in order to separate and classify them. Okay, and these things that are these circles in red are called as the support vectors, and the goal of the hyperplane and the goal of SVM model is to maximize the margins between these two support vectors. And this is how the more is the margin, the more better the classification is, right? So this classification works when the data is linearly separable. But what if our data is not linearly separable? The bunnies and wolves are distributed in this fashion. What do we do in that case? We cannot just simply put a decision boundary like we did earlier. So, what we need to know is that we can use SVMs for linearly separable as well as non-linearly separable data points. So, SVM does that with the help of a kernel trick. So, what it does is that it it just plots the data points in a 3D space instead of a 2D space. Now, in this figure, we can see that here the bunnies and wolves can be demarcated clearly. We can have a decision boundary right here. And congratulations, we've just separated our two classes, which were non-linearly separable as well. So let's quickly jump into the coding part of it. So for constructing SVM models, we can import the SVC function, and we can use this SVC function for the kernel, which is RBF. Basically, RBF stands for radial basis function, and I believe that it is the kernel that is used by default in SVM. So even if you don't write this, it is still going to be working fine. Again, just like logistic regression, we are making predictions, we are evaluating it, we are creating a confusion matrix, printing classification report. And here also we got the accuracy very similar to that of the logistic regression model. So yes, in this case, SVM and logistic regression both are working really fine. Now, I'll quickly move on to random forest. So, a random forest is a supervised learning technique again, just like all the other techniques that we had seen for classification as well as regression problems. It is a trademark of ensemble learning techniques. It consists of a lot of decision trees. So, in a nutshell, what happens in random forest is that all weak classifiers come together to make up a strong classifier. Um, so what we are doing, what we are going to do is that while making predictions, all the trees that are present in the random forest vote for the particular class that they have predicted. You can see that in this figure over here. Different random forest consists of various trees. Each and every tree will vote for the class that they think is correct output for the particular data point, and they will vote. And all these votes are collected, and the class that gets the majority of votes is declared as the predicted output. So this is how simply the random forest algorithm works. So let's quickly jump to the code snippet for that. Okay, so again, as I told you, we'll be using sklearn. From sklearn, we'll be importing this random forest classifier model. And by the way, what are these n estimators? N estimators is nothing but the number of trees that we want in our random forest. So in our case, we are having like 300 trees in our random forest, right? So we'll take these trees, we'll take this model and fit it to our training data, make predictions, and again the routine run of the mill. We print out the confusion matrix along with the heat map, we print the classification report, and we print the accuracy. So as you can see that we got the accuracy of 96.5%. So I think this accuracy is a bit low because random forest works when we have a huge data set, right? And our data set only consisted of like 569 rows. So that's fine. So hence the accuracy is low, but random forest is a very good algorithm in general. So now, since we are done with the top three classification algorithms, I really encourage you all to look into what KNN, decision tree, and gradient boosting and XGBoost algorithms do and how they work. Maybe you can try making a copy of this notebook and try using all these models on this particular breast cancer data set and just play around with it. So, uh, now these were all the machine learning techniques. Now let's just do something much more fun, and let's create our very own first artificial neural network. So a neural network is the way a human brain works. It just mimics the way a human brain works, right? So in this sense, neural networks refer to the system of neurons that are either organic or like either they're organic or they're artificial in nature. So like we humans have neurons in our brains, artificial neural networks or neural networks have neuron like things called as perceptrons or nodes in them. So any neural network has three layers, at least three layers. One is the input layer, the second is the hidden layer, which contains all the weights, and the last one is the output layer, which has the activation function. And this is the layer which gives us the actual output. Okay. So this is what the artificial neural network looks like. The image has been shamelessly taken from Google. So another important aspect of ANN is that there are four important components associated with it. The first one is the input values, which are given to the input layer from the data frame by the user. The second important thing is the weights and bias. Weights controls the amount of importance that are given to various features in any neural network, and bias is just like the constant term which acts as an additional input to the next layer. So the use of bias is that if everything goes, all the inputs are zero, there will still be an activation, right? We don't want our neural nets to learn nothing, so that's why this bias term is important. Then we have the cost function. We have discussed about cost function in linear and logistic regressions. um, this is the same story over here as well. And then last but not the least, we have this activation function, which actually tells what our output is going to be. So these are some important activation functions. This is not the exhaustive list, obviously. If you really want to learn about it, you can just look it up on Wikipedia. They have prepared a nice table for different activation functions. For our use case, we'll be using the Sigmoid and ReLU activation functions. We have talked about Sigmoid earlier, and later on we'll be using ReLU for our neural network. So yes, the disadvantage of sigmoid is that it cannot be used for neural networks with many layers because it leads to the vanishing gradient problem. And that's the reason why we switched to ReLU, because ReLU overcomes this gradient descent, vanishing gradient problem, and performs much better with the larger artificial neural networks. So this was all about the theory part. Now let's take a deep dive into the actual implementation for it. So for creating neural networks, we have leveraged the Keras library. I already talked about it earlier, which is the high-end API of TensorFlow. So for Keras, we'll be using the sequential model, and we'll be creating our the three layers that I talked about: the input layer, hidden layer, and the last are the output layer. So um, so what we have done over here is that we have created two hidden layers with 9 nodes and one output layer. This all has been chosen arbitrarily. So we have used the ReLU activation function in the hidden layer with the HE normal weight initialization, because it has been found out by the researchers and all the data scientists that this is like the perfect combination. They work together very well. Um, Here, input dim is 30 because we had 30 features in our data set, and I decided to use all of them. In the last layer, we have used this activation sigmoid. We've already met this guy. And with sigmoid, it has been found out that Glorot or Xavier initialization works the best. So I have just used it. And then let's take a summary of all these different layers. So we have total 379 parameters. So after creating this model, let's compile our classifier. So here, in place of gradient descent, I have used Adam optimizer. I heavily encourage you all to look into it, what Adam does. How it works, the maths behind it, and stuff. And the loss that has been used is binary cross entropy. We studied about the cross entropy loss in the logistic regression. So if you've forgotten what it is, you might take a look at that as well. So in metric is the one on which we are going to be evaluating our model. In our case, we have used that as accuracy. So let's start training our model for like 100 epochs, and let's see what accuracy we get. So we can see at the end of 100 epochs, our accuracy is 98.24%, which is similar to that of logistic regression and SVM models. And now, when we print the predictions, they are something like this, right? They are numbers, but we want them to be in categorical variables like 0 or 1. So, for that, we are setting the threshold as zero point 0.5. This threshold concept was something that we discussed in the logistic regression. So you might want to take a look at that. So yes, after doing that, let's again print the confusion matrix with the heat maps and evaluate how this is working. For that, we have used the classification report consisting of precision, recall, F1 score, support, stuff like that. And let's look in the accuracy. It is 97.3%, so pretty good. Okay. So here what I have done is that I have printed the accuracy of all the models that we have used, and in the code snippet down below, what I have done is that I have printed bar charts for the same. So nothing great. We already saw how we can create those bar plots. So you can do that as well. So, yeah, that was all about the algorithms that I had. And one final step, if at all you're participating in any Kaggle competition, is that you need to follow the above steps, train your model with the algorithm of your choice, make predictions, and you need to create the submission.csv file. So this can be easily generated using this code snippet below. So it is something I highly encourage you all to do in your Kaggle competitions. So yes, that was pretty much about it. We looked into making a submission, and that was all I had for you today. So congratulations, you've reached your destination. Um, what we just started this journey down the Kaggle lane like 50 minutes ago, and now I think I have given the brief high level overview of all different techniques that and tools that you can leverage for creating your machine learning models. However, one thing wrong with this picture is that this dead end thing is written. I don't think this is a dead end. In fact, this is a new beginning for you. New beginning to learn new things, try out different algorithms, explore how different things are working out. And so, I think after you become well versed with all the basics that we have talked about in today's session, you can look into transfer learning. Which helps us to leverage the pre-trained models for improving our accuracy. You can also start learning about deep learning. You can learn about CNN, RNN, so on and so forth. And so this was like a bonus step, but I heavily encourage you all to take a look at this as well. So now the last slide is that a few caveats that we need to consider if at all you're participating in any Kaggle competition. The first one is that please do not submit the sample submission.csv file just for getting on that leaderboard. Okay, your name on leaderboard means nothing. It really means nothing if you have not learned anything out of the models and the machine learning projects that you're doing. So please do not resort to such unfair means. It is quite demeaning and it is not going to help you in long run. So, and last thing is that you always need to remember that oops is a million times better than what if. Once you have an idea, just implement it. Go crazy with it. Just don't worry about the consequences. Just implement it, see how it works, and if it doesn't, it's fine. We all are human beings and not some pre-programmed devices. Okay? So making mistakes and learning from them is our right, I think. So just I just want you guys to dirty your hands with whatever tricks and techniques that we have learned in today's session. So yeah, that was all about it. Now I'll start my camera, and I'd be happy to take questions if there are any.
Yes. So we have a question. Currently, I am learning ML from Andrew NC on Coursera, where
right?
he has used Octave instead of Python. So, should I continue with the same or should I switch to ML using Python?
So, what you can do is that octaves, definitely we do not use octaves in any real machine learning project. So, that was one of the drawbacks of the course. But the concepts that he has taught in the course are explained phenomenally. Like, he's hands down the modern day Promethean for machine learning. So, definitely you can learn the concepts from that course and start implementing all of that in Python. You can take the help of today's session because we have discussed how you can use Python for creating your machine learning models. So, yes, I hope that answered her question.
Yes. Another question is, can you share these notebooks?
Yes, of course. I mean, AICVS is a society that is democratizing machine learning and artificial intelligence. So, yes, nothing is going to be kept hidden. We are going to share the deck as well as these notebooks. So, there's no need to worry about that.
Okay. Another question. How did you find your passion for ML and how has it helped you till date?
Oh my god, that is one heck of a question. So, to be very honest, I did not knew what machine learning was till like the second semester of my college. I just whenever I used to hear about AI and ML, I used to catch the air of Terminator or Rajnikant's movie Robot that they're going to kill humanity and all that stuff. But what interested me was that I was always interested in how the human brain works, like how different, like all the three sections of our brain, cerebrum, medulla, how things are going on, how it processes, how is it working. So the only way of understanding how brain works, I thought, was to reverse engineer. And machine learning, especially neural networks, are the technique for doing the exact same thing, right? So that's why I got interested in machine learning. My first interest was never machine learning, it was about neuroscience. But yes, nowadays we know that we are like machine learning is really sitting on this intersection of how human brain works. So yes, I hope that answered her question.
Yes. So we have a question. How should we start with ML? Can you tell some resources?
Okay, so for starting off with ML, as I already told you, you need to know at least basic level rudimentary Python would also suffice, and then you can take up the Andrew Ng's course on machine learning. But what you need to be mindful of is that he teaches everything in Octave. You need to do all of that in Python. So Andrew Nang's course is hands down the best thing that you can do with do in your college life. That is the best starting point for learning machine learning. Although it's a basic course, it doesn't even scratch the surface of machine learning, but still, it's a very good starting point. And after that, you can start learning about deep learning, and then as I told in the step 6 of our PPT, that you can learn about these transfer learning techniques and all of that stuff. So, but if you are a beginner, just do not move ahead without learning basic Python, and yeah, try to get the basics of your coding in line, and then and only then start with machine learning. Um, yeah, that was it from my side.
Okay, so I don't think we have any more questions.
Come on, guys, you can ask any questions that you want. This is not a school or college lecture. So, yeah, you can ask stuff that, maybe some stuff that wasn't covered in this session because of we were on this time crunch, right? We had to finish everything within an hour and we have kind of exceeded the time limit. So, it was very difficult covering all these things. But still, if you have any, I'd be more than happy to help. Do we have any questions coming up?
No, not yet. No. I guess we don't have any questions. Your session covered everything very well.
Oh, okay. Um, I'm glad that it was helpful for at least a few of the students who are kind of confused at what needs to be done and stuff. So, since we do not have any more questions coming, I'd like to wrap this up by saying thank you. Thank you so much for giving 1 hour of your time to me. I hope I was able to use it in the most optimized fashion. I tried to cover whatever I could, but yes, I heavily encourage you all to look into the working of it, look into the mathematics part of it, and yeah, just go crazy with it. Put your coding hats on. Like stop this video, register for some Kaggle competition. Just download some data set and play with it. Just apply all the models that you know and see how the accuracies, what the accuracies are coming out and stuff. So yeah, that is the only way you're going to learn. No matter how many sessions you attend, no matter what videos you watch, no matter how many courses you take, until unless you really try your hands at it, you really dirty your hands with it, you are not going to learn anything. So just start coding, smart people. And
Yeah.
I
Uh,
wish you all. Yeah, sorry.
yeah, we have a question.
Oh, great.
Can you tell which problem statements we must do as a beginner?
Okay, so as a beginner, what you should do is that wait, I'm thinking the first one that I did. You can begin with the Titanic data set. So you need to predict the survival of the different people who were there on that boat. So you can begin with that. Then for linear regression, as I told, the Boston house price prediction, and I guess the Kaggle competition that AICVS is hosting right now, that is also based on linear regression, right?
Yes, yes.
So yeah, that is a great way to kickstart your journey. So you can use that data set, you can use the iris data set, you can use the breast cancer data set, then you can use the diabetes prediction data set, you can use the credit card fraud data set, something like that. And then maybe you can use, which one was there? Something, there was this data set, this school data set. It was something avocado price prediction data set, something like that. And if you really want to work with neural nets and all that, you can start working with cats and dogs classification, and then you can use CFAR 10, you can use the MNIST data set, you can use the MNIST fashion data set. So there are many data sets. You will be able to find really good quality data sets on the UCIML repository and Kaggle. So yeah, so just use those data sets.
Yes. Another question.
Okay.
So, if anyone is only interested in ML and wants to get a job in that field, how can it be done? Like, there are few companies only who offer jobs for beginners.
Okay, so even I was struggling with this one, that how to get a job in the domain of ML. So even though everyone says that this is the eternal spring for ML, this is AI is the new electricity and stuff, the jobs, and especially the jobs for freshers, are very limited. So your best bet is to like do some really great, some really good quality projects in machine learning. And by good quality projects, I mean that you're creating some of your own models, or at least you're making tweaks in the existing models, you're improving the accuracy, and you got to make sure that those projects are end to end, and not just all the your visualizations and all that stuff, they should not just remain on the local host on your Jupyter notebook. You need to create some web apps for it. You really need to take it to some another level, and you can maybe put it on LinkedIn or Twitter, because that's how a few cousins of mine landed up with the jobs in the field of ML. But in my case, I was not able to do that, so I had to stick to DSA, problem solving, competitive coding, and grab a SD role placement from the college. So it is difficult, but it is not impossible. but you really need to be very good at it. Is all what I can say. Or you can work with startups that are looking for machine learning engineers. It's a great way to explore those domains as well, and whatever work you will do will actually become a part of their legacy. So yeah, startups is one good place to apply for machine learning jobs.
Okay, so I think that's it.
Okay, so we have no more questions.
Yeah. Okay, another question. Will this session be available after the stream ends? So yes,
Yes.
yes, it will be available.
Okay. So cool. I just want to ask you guys if it was useful or it was not useful. You can just write whatever your feedback was. I'm also very open to constructive criticism, but yeah, just make sure that you don't write really mean comments, because I don't want something to happen that will force me to change my career or something. So just give me your feedback with zero or mild euphemism, whatever works for you. Uh, so I tried my best to cover all of the things. Maybe, it was a lot of information for one session, but I had to make sure that the 1 hour that you gave me, I had to make sure I just use it very properly. Yes. So I wish you guys all the very best. A flamboyant, data-driven journey and a bright future awaits you all, because you took this initiative on about learning machine learning, that too on a Sunday. It's a very big deal. Okay, so most of the people might be in their beds lazing around. Some of them might be having their breakfast, but you actually attended this to learn something new. So kudos to you all. Don't worry, everything is gonna work out fine. Those were my closing remarks. I'd
Uh,
be happy to take more questions if there are any.
I think there is one more question.
Okay.
Yeah. Overall, it was a really amazing session.
Thank you.
Yes. So the question is, can you tell me how to start with a neural network?
Okay, so for learning neural network, the best starting point was, you can take reference from the code that I gave in today's session, because it was like the most simplest possible neural network that one can ever construct. It just had 3 layers, and so this is your starting point. And later on, what you can do is that you can do the deep learning specialization by Andrew Ng. So in that, he explains how will you create neural networks, and not just that, he also takes it to another level by explaining you about how will you construct CNNs, RNNs, and other cool things like LSTMs and stuff like that. But if you're asking about the starting point, I think this session, the last section of the session where I discussed about neural networks, that can be useful. And later on, you can do the deep learning specialization.
Yes, okay. So that's it. Thank you so much, everyone.
Thank you, guys. Thank you for attending the session. I hope you all had a great time, and stay safe, stay at your homes, okay? And keep learning about ML and DL and stuff.
Okay. Thank you.
Thank you.